Hey everyone, Schlager here. We're going to do part 2 of the CAPS College Algebra 3.2a notes. The focus of this lesson was on factoring, and we have just a small selection of word problems to look at. The first example reads, the height of a triangle is 2 fathoms less than the base. If the area is 60 fathoms squared, what is the height and the base of the triangle? All right, so I don't know why we have fathoms here. 1 fathom is equal to 2 meters. So we're going to just say that this is 4 meters. Okay, and then we're going to say that this is 120 meters squared. Right? Am I allowed to do that? Let me think about that for a second. Yeah, we're going to try that and we'll see what happens. Okay, so we're going to change those numbers and just make life a little bit easier. That 120 I don't think is going to work out, but we'll see. So the height of a triangle. Well, hey, I better draw a picture of a triangle. So I'll make it just a standard triangle. Actually, why not? Let's make it a right triangle. We'll make it really simple to look at. And it's 4 meters high. The area of the triangle, okay, is 120 meters squared. That's the area of the triangle. In fact, here, I'll do this. I'll delete that. And I'll just put this number, shrink it up a little bit in there. There we go. All right. What is the height and the base? What is the height and the base of the triangle? Well, we know the height already, so that's nice. That's just wonderful. All right. So the area formula for a triangle, it's probably going to be a useful thing to have. The area formula for a triangle would be base times height divided by 2. And in this particular example, I know the area is 120. I don't know the base. I do know the height. And I have divided by 2. So there we go. So I'm going to do a little bit of solving here. Times 2 times 2. I get 240 equals base times 4. Divide by 4, and I get 60. Okay, I get 60 equals the base. 60 meters. Quite a big triangle. Okay, so that was a pretty boring question. And in this question, although we had something squared, we ended up not needing to really do anything quadratic. 2 consecutive integers have a product of 210. What are the 2 integers? Now, this is an interesting question. Now, an integer is just a number, right? An integer is just a number like 1, 2, 3, and consecutive means they are just back to back. Like 3 and 4 are consecutive integers. 7 and 8 are consecutive integers, right? So we're going all the way up to, 2 consecutive integers have a product of 210. Okay, so we don't even know how far we're going, but we know that the 2 integers have a product. Remember, product means multiply of 210. So what's a way that I could express 2 consecutive integers? Well, if my first integer is x, then my second integer could be expressed as x plus 1, because if I add 1 to it, I get the next integer, right? And the product of these two would just be whatever they multiply to. And they tell me in the problem the product is 210. So if I distribute, I get something like x squared plus x equals 210. Or x squared plus x minus 210 equals 0. If I subtract 210 from both sides. So I've got a situation now where I have a quadratic that I need to solve. I need to solve this quadratic. So I'm going to get my target product, target sum table out. A times C and B. And then I'm looking for two numbers that multiply to negative 210 and add up to 1. That means that these two numbers are going to be very close together. Very close together. They're just going to be 1 apart. So I'm going to cheat a little bit. I'm going to take the square root of 210. 14.49. Interesting. So 14.49 times 14.49 would give me 210. So I wonder if 14 times 15 would give me 210. Ah, yes. See, I knew the two numbers were only 1 apart, so they had to be really close to the square root of 210. That was pretty clever on my part. They have to add up to 1, so I'll make the 14 negative. Those are my two numbers. That means my two factors are x minus 14 and x plus 15, which means my two answers are x equals 14 and x equals negative 15. Well, now hold on just a second. Those two numbers don't meet the criteria of the problem. The problem said two consecutive integers have a product of 210. Well, just hold on a second. I already figured out what two numbers have a product of 210 that are consecutive, meaning back to back. The numbers were 14 and 15. So during the solving process, I ended up with, a negative sign. But that just helped me pinpoint what the real numbers were. Once I got the numbers, I just had to apply common sense and understand the question, what was being asked. I found the answers. I just needed to realize that. Robert threw a rock off a bridge into a river. The distance from the rock to the river is modeled by this equation, h, which stands for height, of t, which stands for time, equals negative 16t squared minus 16 plus 60, where h is the height in feet and t is the time in seconds. How long? We are searching for a time. How long did it take for the water, or for the rock to hit the surface of the water? For the rock to hit the surface of the water would be a height of 0 feet. That's important to realize because that means that I'm going to take the function given to me and I'm going to plug 0 in for the height. I'm going to take out a greatest common factor of -4. What that's going to do is simplify this equation a little bit. Fantastic. So the numbers are a little smaller. Life is a little easier. target product, target sum. I'm just looking at the quadratic in the parentheses. So I got negative 60 and 4, which I can split up into, well, we better just go down the line here. 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 8. Not 5 times 8, what am I saying? 5 times 12. Okay, 6 times 10. 6 times 10 can make 4 if the 6 is negative. Awesome. Now, because my a value is greater than 1, I need to be careful. I need to use the box. So I'll put my negative 6 and my positive 10x into my box, factor out my greatest common factors. Now, I knew I would do this. I replaced the letter x with the letter t. There we go. All right, my greatest common factors here, 2t and 5, 2t squared and negative 3. All right. So I've got 2t squared minus 3 and 2t plus 5. Oops, I have a squared in there. I apologize. There we go. Much better. All right. So if I take each of these aside, I've got them set equal to 0. I'm going to get 3 halves for one of my answers and negative 5 halves for the other one. Now, what I've found here is this. What I've determined here is that when this rock is thrown off the bridge, it starts out at a height of 60. I can see that from my given quadratic. That's the y-intercept. And it's going to be thrown probably up and then come back down and hit the water, splash. It's going to hit the water at a height of 0 feet. And it's going to do so in 3 halves. Let me use orange. In 3 halves or in 1.5 seconds. Now, I chose that answer right here because that's the positive answer. It is true that this quadratic goes back this way, back in time, negative 5 halves or negative 2.5 seconds. But of course, in the context of this problem, that doesn't make any sense. We can't go back in time to see where the rock would have come from if it was thrown from the water in the past. So, 1.5 seconds is the answer. Thanks for watching, and we'll see you next time. Bye.